Hello, and welcome back again to Lecture with Daggett. Okay, it's a working title. We'll see how it develops. So, where are we today? Going to talk about amps and speakers. So we're at the end of the speaker chain. Now, what are amps? What are they? Do they do? Amps bridge that voltage gap from one device to another. Now, there's three main voltage gap or voltages that we use in our systems. First is microphone level, and this is the lowest. This runs between 0.001 volts and 0.010 volts. Very, very, very low levels. This is why microphones tend to get the interference. This is why we use balanced cable. Up from that is line level, and at the professional stage, we use 1 volt is about the where those levels lie. Um, then above that is that power level, and this is where speakers happen, and this is where we actually have real power that goes through our system. We could have as low as a 100-volt constant power system, and they can get up and up with several hundred watts, and it goes even higher. Now, that doesn't mean these are the only voltages that we use in our systems. There are some older style voltages that kind of run the gamut in between these levels. Specifically, if anybody decides they want to use the turntables and mix that way, yay DJs, and do it old school. There is a specific phonograph level that runs at zero point 0.3 volts that you need to have a very specific preamp to get that preamp from the phonograph to line level signal. It's specially made. You used to be able to go to Radio Shack and grab one, but Radio Shack doesn't exist anymore. So you got to order one online. So to get us from microphone level to preamplifier level, we need to use a preamp. It used to be that they were set voltages specifically set to pair with that microphone. So you would have this really, really nice, expensive microphone. There was a preamp built specifically for that. Now, that being said, there are some preamplifiers out there that are specifically made for certain microphones and sold as a pair. Barkus Berry is famous for pairing their microphones with a very specific preamp or a very specific DI box that is active, which means it has a preamp in it, which means it needs phantom power. It all connects. Um, but most microphones these days don't have that set preamp because we have that variable gain knob, which means we have a non-set voltage and we can choose what voltage they have it. Now, not all preamps are created equal. If you look at the bottom of my screen, there are a couple true preamps. They're considered the best of the best. And if I remember correctly, the last time I went to buy them, they were worth more than their weight than gold because you could actually buy gold cheaper than what they were being sold for if they were sold by weight. I personally have this Piece Solo preamp made specifically for ribbon microphones, and it's for my ribbon microphone that's a little bit twitchy sometimes if you don't plug it into the special preamp for it. It does work, but it is not the best preamp for it. So, amplifiers. This gets us from line level up to power level. Now, basic amplifiers have only a few functions. They might have a low cut on them. They might have a high boost on them. They might be able to bridge, which is a function we don't really use that much, which means it takes two channels that it has and connects them together in a very specific way that only allows for one channel for that amplifier, but it allows you more power, not double the power, more power. Normally it's an extra half times depending on the amp. Amps these days have a lot of extra features built into it, not just with that attenuation or amplification knob, but a lot of them have equalization built into them, delay, detection of a bad speaker if it has a speaker that it doesn't recognize, temperature control, signal, etc., etc. There's a set of amplifiers that if any of you have watched The Beatles Love or know The Beatles Love, that Cirque show, there is a position there that an audio technician has. Now, it's in rotation with a couple other positions, but there is one position that during the show, they sit there in front of the screens and monitor the amplifier levels. They are all networked into a single station, and you can tell exactly which speaker is running, at what SPL level, what temperature that speaker it is, how much longer that speaker has in its estimated lifespan before somebody needs to go and run some maintenance on it. There's so much technology in that set of amplifiers. Most amplifiers, you don't have that still, but you do have a lot of equalization, and you can do some um, biamping with certain amplifiers built in right into the amplifier. Now, something that doesn't often get said in intro level classes, but should be said just so that you guys start getting the idea of it, is speaker to amp matching. Now, I am not expecting anybody in this class to have the abilities to actually put this into practice, other than to get the concepts so they don't run themselves into too much danger. Because the last thing I would want is to have no idea how to match your speakers to amp and kind of go on without that idea, and either put a amplifier with too much power onto a speaker, or what might just be as bad is to put an amplifier with way less power than the speaker needs to be able to run. And either way, it's going to be bad news bears for the speaker. So both the speaker and the amplifier will have a wattage listed on their spec sheet. They'll have a nominal wattage, which is considered the wattage that they are expected to be run consistently over a long period of time, and a peak wattages, which is the most wattage that you can expect that amp or that speaker to ever be able to run. Now, resistance, which we'll go a little bit over resistance, kind of brush over it, is notated by ohms. This is set by the speakers. The speaker and the cable is what gives resistance in the system. Based upon this resistance, tells you what that amplifier's wattage can handle. Because if it's only 4 ohms, that amp might be able to produce 1 wattage. And if it's 8 ohms, it'll be able to produce a less wattage because it'll have more resistance on that system. So there are 2 basic ways that people use to match speakers with amps. And 2 basic ways you can try to help yourself not get into trouble if you're matching the 2. One is to match the nominal rating of both of them. So you would look at the speaker, and it says that its resistance, for instance, is 4 ohms, and the wattage, its nominal wattage, is 600 watts. So you would go and you would look at amplifiers, and you look at amplifiers that at 4 ohms of resistance, it can output 600 watts. 600 and 600, and we're equal. That is a good way to go. The problem that I find, or the big danger with it, if you have unexperienced people working the system, that you probably want to put a limiter in line, because there is a good chance for you to be able to peak both the amp and the speaker, and you end up blowing well, more than likely you'll blow the speaker before you blow the amp, but you could damage both of these units. What I will tend to do when I'm putting together an install, especially it's for a place that, say, students will interact with, or say the community will interact with, or say a church, any place where I expect people who not quite know what they're doing fully and might overrun that system just a bit, I'll end up using the second system as a guide mark for setting it up. So what this does is you look at, again, whatever speaker you're thinking of, and it has a nominal rating of, let's say, 1,000 watts. Okay, great. Then you find an amplifier that at that 4 watts has a peak rating of 1,000 watts. So what this does is that no matter how hard you push the amplifier, you're not going to be able to peak this speaker. This will keep that speaker safe. Now, on the corollary to this, you don't want to do the extreme of this and put a 25 watt amplifier on an 800 watt speaker. You want to make sure that it keeps relatively the same. You're just off that little bit. If you try to do that, you could clip that amplifier which will then send that clip speaker to the speaker, which will then send a really nasty DC signal to the speaker, and then your driver will go all the way in or all the way out, depending on which phase it is at that specific moment. And then you can also blow your speaker. So you are looking to keep these within, at least a couple 100 watts within that 10% range. But this is the way to make sure you're less likely to blow your speaker. So if you are connecting multiple speakers together, now a lot of people like to daisy chain their speakers, which daisy chaining just means more than one speaker. You connect it in, daisy chain. Here's the formula that you would technically use to calculate this. You would use 1 over Z1 over Z2 over Z3, and you'd connect, and I'm not expecting you guys to know the formula. So hopefully you guys looked over the Bill Nye the Science Guy. If not, there's another video on series versus parallel. In that connecting in series, you go from the amplifier or the power source to one unit, and then you go directly to the next unit, and then you go back to that power source. And in parallel, you run it from one speaker back to that amplifier, and then the other speaker back to the amplifier. 95% of the time when you are wiring speaker, especially if you're daisy chaining through that back port of the speaker, you are putting those speakers through parallel. It is very rare that you would put them in series, and most of the time when things are in series, they're specifically wired for things like the line array that you'd use. Most of the times those are in series, or if you're doing a specific front fill or underbox setup that you are installing and you have done the install setup, then you would set them up in series. So, given that ohms are the same, and if you are connecting multiple speakers together, the ohms should be the same because you should be connecting the same speaker. But given that, when you are connecting things in series, all you have to do is add the ohms. 16 ohm is the common limit that most amplifiers can handle before they start to overheat. That being said, Crown is a very popular style of amplifier, and it can go up to 32, and there's one model that I've seen that can go up to 64. Most amplifiers can't handle this. Most amplifiers, 16 is that common limit. So it's really, really it's simple. If you have like 2 speakers, and those speakers are 4 ohms apiece, and you wire them in series, 4 plus 4 equals 8. 8 ohms, we're under 16, everything's good, everything's lovely. The other way, and again, this is the way that most of the time you will connect your speakers together, is to run them in parallel. So to do this, you divide the ohms by the number of speakers, given that the speakers are exactly the same and the ohms are exactly the same for the speakers. So in this case, say our speakers are both 8 ohms, we have 2 of them. 8 divided by 2 equals 4. 4 is greater than 2, which is the common minimum. We are safe. Now, that being said, there are some amplifiers that can run below 2. Again, Crown, very, very hardy brand of amplifiers. There are some amplifiers of Crown that you can run them down almost to 0. When I say almost to 0, Rick actually tried an experiment once with a series of amplifiers, and mathematically it was worked out to 0, except there was a little bit of resistance added in the cable, and that amplifier was still churning. We're not sure how, but it's the magic of Crown and the magic of Rickness. So, most of the time, say you have 2 4 ohm speakers, which is the other popular ohmage. Most speakers are either 2 or 4 ohms unless it's for a specific purpose. Again, 4 divided by 2 equals 2. You're safe. As a general rule, you're almost always safe daisy chaining 2 speakers. It's when you have more than 2 that you want to start to actually do the math and do the real math on it. Now, there are special made speakers that have more ohmage that are also defined specifically to be in certain patterns. Like there is a set of speakers that are all 16 ohms because they are specifically designed for front fills, and they are expecting that you use 4 of them together. 16 divided by 4 equals 4. So you can use most amplifiers as long as you use all 4 of these speakers in parallel like they are designed. The other very specific type of speaker system that you guys have probably all listened to that's a little bit different than our normal set is the constant voltage system. These are also known as high impedance systems, and they're kind of interesting because instead of worrying about resistance, all you're worried about is the wattage. If you've taken lighting class before and you've ever done ME paperwork and you try to figure out if I can put this many lights on a circuit, all you're doing is adding up the wattage and making sure that's underneath what that circuit can take. So, for instance, if you have four source fours and they're 575 watts and you have a normal circuit breaker at 2400, you can use four source fours. If those four source fours are at 750, then that exceeds that 2400 and it would pop the breaker. This kind of works the same sort of way, in that you would have a bunch of speakers. And the nice part about that is you can wire them in any way you wish. Um, Series, parallel, it doesn't really matter because you are tapping into a powered system is how it looks at it. And then from there, all you're doing is adding that wattage. And as long as you leave at least 80% for safety, so if you have an 100-watt system, as long as your wattages only add up to 80 watts, then that's considered safe and considered good. You see these all the time in any of the Targets or Walmarts or any place where you need a lot of speakers that don't sound so well. In our classroom, we don't have one yet. Once they do a remodel, they would be required to install one because a lot of fire safety systems require that you have one installed as part of their public address system in case an emergency happens. The other cool thing about these is they are tapped. So if you look at our nice picture there, you will see one of the wires that's black that says common. This is the wire that you have to connect no matter what. The other three wires have different wattages on them. You can choose which wattage you need for that individual driver based upon where it happens to be. So if you were setting up these for our green room, you set it up in the main green room area, you might want the 10-watt setting. If you set one up in the Diva's dressing room, you might only want the 2.5-watt setting. This makes it nice because you don't have to adjust the main volume and you don't have that extra control, but you can have some extra control of the volume inside of it. Different types of speakers. Main one that you guys have probably seen is the horn speaker. So hopefully everybody has seen this. This gets used all the time in the football stadiums. They use a compression driver, and the reason they use these is the same reason that cheerleaders like to use their horns during cheers, is because it focuses the voice and focuses it out. It adds amplitude to it because of that focused energy. Now, unfortunately, that focused energy also means that you have some weirdness in certain frequencies and you end up getting that stadium sound. Personally, I don't care for the stadium sound unless I'm trying to really recreate the stadium sound. And then I do actually grab one of my horn speakers that I have in storage and play that through the horn speaker just to get that through an actual stadium sound. Um, these are really, really, really popular at stadiums, high schools. You've heard them. If any referee has ever said anything ever and you've listened to it, except in the brand new football stadiums that are out recently, this is what you're listening to. So, trapezoidal speakers. We are going to take our eventer, two speakers, and all the different parts of it. If anybody have watched Monty Python. Coconuts. Coconuts are the way we create horse noises in Foley. So we don't have to actually have the horse. Still used today. Amazing. So, speaker features. A couple things that you probably should look around if you ever buy one. One's the wattage. Another's the resistance. Now, wattage, of course, is how much wattage the speaker can handle. I've had some people that considers that, oh, that's how much the wattage puts out. No, that's how much the wattage it can handle. It does not directly convert into SPL output. Generally speaking, yes, the higher the wattage, the higher the output, but that's not exactly true because you can have a lower wattage, more efficient speaker, or you might be able to have um, a speaker that only reproduces in certain frequencies, which ends up adding to the SPL in those frequencies, which makes it feel like it's louder, even though it's not actually louder. So efficiency, and this is has more to do with how well that electrical energy, that transducer converts that electrical energy back into acoustical energy. So the more efficient a speaker is not always better. Um, for instance, horn speakers are super efficient, and you can get really high SPLs because they're super efficient, but they're not that accurate. Hence, horn speaker sound. So it's better to be more efficient, but only to a point. You still want that full range sound. And then sensitivity. So this is the minimum amount of electrical signal required to make a sound. So there is an amount of sound that you need to be able to push it. So the two diagrams I have are this dispersion or splay patterns. And we'll talk about this again once we get into line diagrams. But every single speaker has a dispersion or a splay pattern in which it's, well, outputs the signal. And this is the optimal path of which that signal is going to reach. If you've ever taken lighting class, or if you even have a flashlight, think of it the same way as a flashlight. If you point the flashlight that direction, then the light's going to go that direction. Speakers are sort of the same way. They all have some sort of splay pattern, which tells you at what angle the optimal amount of acoustical energy is going to hit X, Y, or Z spot. And this is both in the vertical and the horizontal. And some of them you can adjust, that you can take the horn, you can flip it around and switch it from horizontal to vertical. So it becomes important to make sure you have even coverage, to make sure that either A, this display pattern is wide enough for the coverage you want, and B, the display pattern is not also too wide, because you can get the display pattern being wider than you actually want and actually cover more than you want, and you end up covering the walls, and this causes other problems if you end up covering the walls. So just something to keep in mind when you're matching your the speakers to the purpose you want to, not cover the walls. So some extra features that you will see in amps or speakers is whether they're passive. Remember, passive speakers need that external amp, or whether they're active or self-powered. So these are the ones that have the amplifiers built into them. These will have Edison plus XLR built into it. So really, really easy to tell the difference between passive and active. If you know your connectors and you look at the back of the speaker and you see that it has a speak on connector, that is a power level connector. That speaker is going to be passive because it needs that speak on. Or if it has a 1/4-inch jack in the back of it, or if it has a banana jack in the back of it. On the other hand, if you see on the back of a speaker that it has XLR, which is line level, and PowerCon or a IEC cable, those are both giving you power to that amplifier, but the signal's passing through that XLR. You know that it's this active or self-powered speaker. They also make wireless speakers the same way that you have wireless microphones. There's wireless speakers that gets used. If you ever work for PSAV, you will find these used on a semi-regular basis because people love their beach weddings, and it's really hard to run power out to the beaches. So what do? You get a couple battery-powered wireless speakers paired to 1 or 2 wireless microphones, and you just set it up and set it and forget it, and people can have their dream beach wedding over in Cocoa Beach. So parts of loudspeakers. The biggest part, and the part that we see the most often, is that enclosure. So that's this wooden part out here on the outside. Well, in this case, it's faux wood because it's not really wood. It's not even plywood. It's like cheese grated board stuff. In any case, the enclosure is the big part of it, and the part that normally makes it heavy out of the magnet. There are two styles of enclosures. One's the closed back, and you see that on that top portion. And the key thing of the closed back is that even though that it is sealed all the way around, except for one part, the port. Let me manage my microphone. The port. So ideally, this port is engineered in a way that it is exactly 180 degrees out of phase from the system, so that as the speaker moves forward, or the driver moves forward, it is sucking air out of it. If that port is done correctly, then it's actually also moving that acoustical energy forward as well, because the port is 180 degrees out of phase. Not all speakers are created equal. I'm sure that one is not. The other style that you will see if you ever work with old guitar amps is the open back system. Now, I know a lot of people who like that open back system, but the big disadvantage with that open back system is you have acoustical energy moving backwards. That being said, this used to be the only style. If you watched Phantom of the Opera when it was originally debuted, the speakers that were in the main system were all open backed. 60s Ducks saw that show, enjoyed it, but wondered why they were using open back system even back then. There's a whole theory and there's a whole math behind it. It actually sounded quite good, but nobody would do that now because we're all using line arrays. So parts down. That driver, that central portion, that moves back and forth, is also called the moving coil. What else is known as the moving coil? I'll give you a second. Pause the video now if you want to try to look in your notes and see what the answer is. Okay, ready? What else is that moving coil? Well, a dynamic microphone. To the point that the Beatles kind of premiered this. They wanted a little bit more sound out of their kick drum. And the microphones at that time didn't do so well with the kick drum. So what did they do? They wired a speaker and flipped the wiring, and it became a microphone. This is a concept that now exists. You can buy this Yamaha Subkick, which really all it is a speaker wired so you can plug an XLR into it, and that you can get a little bit more sound out of your kick drum. So there are a couple different styles. You have full range loud drivers. Those respond over the entire audio spectrum. You have mid-range, which works primarily to where our vocals are. And then you have these cool coaxial speakers. The coaxial speakers was originally invented and used in car systems. Why? Because they save space. You have both a woofer and a tweeter, and I'll go in those in just a second, but you have them all in one driver system. They get used a lot. There's a brand of monitors that have been using these coaxial speakers. They sound pretty good. Not great, but they sound pretty good. I'll use them on a regular basis. So, different driver types. We have our tweeter. So these are our highest and smallest, hence tweeter. Tweet, 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 birds tweet, high frequency, tweet, tweet. Please get this one correct because people forget that birds are high pitched, hence tweeter. Tweeters are high pitched, tweet, high pitched. Then below this we have barkers. These are our mid-range drivers. They're between 3 and 6 inches, and normally this is in loudspeakers enclosures that you have 4 or more drivers. So if we looked at our last slide, you see that speaker right on the right that has 5 drivers on it. That top one would be a tweeter, and then next would be a barker, and then the one below that would be a woofer. This is our low to mid-range driver. Normally these are full range drivers. Normally these are a little bit beefier. You find these on a lot of our heavier speakers. They're between 6 and 16 inches. Normally they're between 9 and 12 inches, but you do have some bigger woofers that are made to go through the full audio frequency. At last, but certainly not least, although it is in frequency, is our subwoofer. These are our low range drivers. These are what really gives our bass boom and our kick. So these can be 12 inches and greater. The one in there, I believe, is a 20-inch that was used for a fun experiment that they put some low frequency through it, and you can put some cornstarch through it, and it makes the cornstarch do some cool little diagrams and designs, and it's all fun. But they can get really big, up to the point that you have this guy, Super Sub. Yes, that's an actual sub and an actual car, and that car can actually drive. There are sub test competitions out there. Last record that I had notation for, they were able to get the interior of their sub at 181.1 decibels. Do not be inside of the car. I hope they turn the volume down before anybody sits there, because one of the competitions is to have a car that is fully functional, and you have to drive it to the test site and then get out, close the doors, and then test the decibel level. I hate if you forgot to turn the volume down before you turned it back on, because then it means you can't hear. I believe I added a video for you guys of somebody who will be losing their hearing very shortly because, well, they were inside of a vehicle doing one of the sub tests, and then you see their shirt wave around like they're in the middle of a hurricane or at least a good windy storm. Hearing protection, guys. Hearing protection. So the other thing that most speakers will have is a crossover. Now, passive active is also used for whether or not a speaker is passive or active with their powering. A crossover itself, and you'll hear it referred as to the crossover between passive or active. So a passive crossover. So the crossover itself, let me start there, splits the frequency into of any driver. So you have a speaker who has more than one driver, and normally it'll have a low driver and a high driver. Sometimes it'll have 3 or more drivers. It will split the frequencies so that each driver gets what it is most efficient at transmitting. So the tweeter will get the high frequencies, the barker and the subwoofer will get the low frequencies. If it is passive, that means this crossover was set by the company using math that they considered the best optimal way for the speaker to be set for every single purpose out there. Okay, great. Active means it's adjustable by the user. So either you can go in electronically, like the QSC K12, K2 systems allows you to go in electronically and adjust this, or you buy amp the speaker, which means that lower driver has 1 amp, that higher driver has a second amp. Buy means 2 amp. You need 2 amp channels to power this. And you are able to control each because you have a crossover somewhere. Normally it's inside the amp now, but it used to be a separate processing unit, and be able to control where that crossover point is. So where the low speaker has frequencies that it's sending, and that high speaker has frequencies that it's sending. You can do some cool things if you buy amp a speaker. I did an experiment in grad school at the music program there, bought some Martin Audio wedges, and they were toting that they spent all this money on and they sounded excellent, and we were still using a set of clip shit wedges. So I took it upon myself to unwire the clip shit wedges, put them in biamped mode, made a custom crossover point, do a custom equalization on it, and I was able to get them sounding better than their Martins. They were not pleased at me, but they were also entertained. What do you do? I don't know sounding art. What do you do? So, parts of a driver. We will start and go around. You will see these on the test. Make sure you know the parts. So, spider. This provides suspension to the speaker and the inside of the speaker. This is one of the 2 parts that will wear out really quickly. The other is the surround. So Down below is the voice coil former. So when in the inside of the speaker, there's a tube. The cardboard tube is the voice coil former. The voice coil is the metal ribbon that, or the metal wire that wraps around it. The dust cap is exactly as it sounds. It protects the inner parts of that driver from dust, hence dust cap. We like it. The cone or the diaphragm is the big, huge section that you see moving back and forth. This is what actually moves the energy the most. This is those paddles. If you were in one of those wake um, ocean board things. So sometimes it's called a cone, sometimes it's called a diaphragm. I will count either or. They're both correct answers. The surround is the other part that goes bad really quickly, and I don't know how many surrounds I've seen and had to repair. Luckily enough, most of the time the surround is fairly easy to repair. It's just time consuming. So if you have an old pair of 70 speakers and the surround has gone out, you could throw them away. But if they're nice quality speakers, go to eBay, buy yourself another set of surrounds. So at that bottom, we have our frame or our basket. Potato on the name. I will count both as correct. This is what supports all of those parts to the left. Then we have the magnet, and this is normally a heavy magnet, and you could use it to stick the entire speaker on your fridge as long as the magnet on your fridge was strong enough to be able to hold it. But I've used them as old drivers as well. You put a couple coupons underneath and you stick it on the fridge in the break room, and people are like, it's funny. So we have our voice coil, and this is where that tube comes in. It's the actual metal piece that wraps around the tube. Then we have our magnetic gap, and this is the gap between the voice coil and the magnet. And then we have our magnet assembly / pole piece, depending on who's calling it. And this is what holds that back half with the magnet together to make sure it attaches to the frame or the basket. Now, hopefully you guys are looking at your parts, but I have one other diagram for you. There we go. So voice coil, magnet, frame, basket, cone, diaphragm, those are the same terms that we had from the other lecture. The big thing that I want you to see is that on every speaker, there's a signal input output to it, depending on whether it's in or whether it's out. Normally it's red and black, sometimes it's other colors, but there is a place for it to get signal. You have that hot, and you have that neutral, plus minus, and that's what provides power back and forth. Now, with any speaker, you also on the back of it have a connection panel. Now you see these two connection panels right here. The speaker has speak on, and it also has our 1/4" jacks. So you know what type of speaker this would be attached to? Yes, passive speaker. It'd be on a passive speaker, because if it had XLRs and an IEC connector, then it'd be active, but it doesn't. These are examples of two passive speaker ports. The last thing that I want you guys to be aware of, and that is because they've gotten intensely popular lately, are line arrays. Now, line arrays are kind of interesting devices because what it does is it takes a stack of drivers and a bunch of speakers, stacks them all together, uses phase cancellation in a conducive way instead of a unconducive way like we normally think of phase cancellation, to allow you to throw that sound further more evenly over long distances. So it uses the inverse square law. And for the purpose of the class, we don't need to know what it is. But it does that to create a line source system. Now, what's kind of interesting about these is that you have to have them so tall. And if you don't have them so tall, their frequency range of which they are able to control is directly proportional to the height of which they are, which is why you see line arrays that are of super tall properties. Um, because of that, if you ever have to work in a place where you have size limitation, line arrays aren't necessarily the best thing to do. On the same token, they aren't always the best sounding speakers in the world. That being said, you have your Meyer, you have your D&B, you have your L Acoustics. They are really, really excellent and they know what they do, but you're also looking at a 15 to 20 foot line array. There are places, and especially if you're in a smaller space, that you might want to think about foregoing the line array and just using regular trapezoidal speakers. You can do well with regular trapezoidal speakers as opposed to line array, especially if you're in a room of, say, 50. Now, if you're in a room of 50,000, you definitely want to use a line array. Now, the tricky part about line arrays, of course, is you do have to make sure that it's tuned. You have to go look at the software, tune them, figure out what size of room you're in, what the dimensions of the room, put in a CAD drawing in a lot of times. It does require a lot of math to be able to use correctly, but once you tune them correctly, it sounds really nice. So, with that being said, have a good day, and I will see you at next lecture.